In this section, we're taking a look at what are called complementary angles and supplementary angles. We're going to look at the algebraic relationship between these angles and also the geometric relationship. In other words, what does it look like when we have complementary and also supplementary angles? Before we start doing anything algebraically with them, we need to know what is a complementary angle and what is a supplementary angle. So in this activity, we're looking to define what complementary angles are. So we have this table of values here, and the first row is a measure of one angle, and then the first column is a measure of another angle. And these yeses or nos are showing us when the angles are complementary or not. So in other words, 18 and 72 are yes. The 18 and 42 are no. So what I'm going to do first is highlight all of these yeses. We're going to see if we can get to a definition of what complementary angles are, if there's a relationship between them. It looks to me like if we take 18 and 72, we get 90. 27 and 63, we get 90. 30 and 60 together, we get 90. Any of these relationships that have this yes would add up to 90 degrees. So based upon the table above, formulate a written definition of complementary angles based on their measurements. My definition is going to be complementary angles are angles that add up to 90 degrees. Right, and we can see that in the table that that's true for all of those relationships. So geometrically, we're trying to think about what does 90 degrees actually mean. So what would it look like if we put together two angles that add up to 90 degrees? Well, if you think about this, a 90-degree angle is a right angle. And so we take any two angles that form that, and they would create that right angle. It doesn't matter what this one is. Maybe this is, I don't know, 50 degrees, and this is 40, or any relationship there, as long as they add up to 90 degrees. So if we put them together geometrically, they would form a right angle. Okay, so that's the geometric relationship. The algebraic relationship is that they add up to 90 degrees. In question 3, we're trying to tie this back to what we did in Algebra 1 with our functions. We want to write the complement as a function of an angle, because it is. It's always going to have that same relationship. So we're going to say the complement of angle A. So again, this is our output, this is our input. Complement of angle A would be 90 degrees minus angle A. That's our function definition of the complement. Then we're looking for any restrictions on the domain, which is the inputs of A, and on the range, which are the outputs of C. So the inputs here, we're trying to think about angles that don't exist. We know that if we had like a 100-degree angle, if we took 90 minus 100 degrees, we would get negative 10 degrees. Technically, the angle exists, but for our purposes, it doesn't, because we're only going to measure things between 0 and 360 degrees at the end. We're talking about angles, though. We're really looking at 0 through 180. So are there any restrictions on the domain? Yes. A must be greater than 0, because again, a 0-degree angle doesn't exist. And less than 90. And the reasoning was the same thing we said there. If it's over the 90, we're going to get negative angles, and that's not a good thing. Are there restrictions on the range C? Well, so we're looking for kind of the same thing. A complement, whether I pick the angle or its complement, together they have to add up to 90 degrees. If I flip-flop these guys right here, I should have the same restrictions on the outputs. So, yeah, there are restrictions on the range. And C has to be greater than 0 and less than 90. So same restrictions we had on angle A. So in activity 1B, we're going to use that idea of complementary and do some algebra with it. So here we have which of the following are examples of complementary? Justify each of your responses. Again, the idea is we're going to add them up to 90. Don't go by the picture, but the addition of the angles. So if I take 35 plus 55, that will give me 90. So yes, and my justification is 35 plus 55 equals 90. Look at number 2. If I have 60 plus 20, that's 80. So that's no. 60 plus 20 does not equal 90. And then 3, 50 plus 40 is a yes. So 50 plus 40 is 90. And then we're going to find the complement of angle A. If it's not possible, then we're going to write does not exist. Or I'm sorry, if it doesn't exist, we're going to write not possible. Where appropriate, write our answer in terms of x. So we're going to take, our function that we had was c of a is 90 minus a. So we're going to do that. We're going to plug in a, which in this case is 26. So 90 minus 26 is 64 degrees. If I try this in number 3, I do 90 minus 105, and I get negative 15, and that's not possible. Again, it's over 90 degrees, so we have a major concern. Let's jump down to a more challenging one. Let's look at number 6 here. We're taking this same idea. We're going to take 90 minus the angle. When we do that, though, we have to make sure if we can combine like terms, we probably should. So we're going to distribute this out, that negative. We're going to get 90 minus x squared minus 3x plus 8. We're going to add like terms. I've got 90 and 8 is 98 plus 3x. So that's my complement of the angle. And let's pick a couple problems here to do. So angle 8, so number 8, angle A and angle B are complementary angles. So I'm going to highlight the complementary. A is x squared plus 24, and B is 60 minus 5x. Find both possible values of x. So let me highlight A and highlight B. And we're going to create an equation here. So A we said was x squared plus 24. Oops, grab the wrong one. There we go. And then B we said was 60 minus 5x. And because they're complementary, we know they have to equal 90 degrees. I'm going to look to combine like terms, so I've got an x squared minus 5x, and this is plus 104 equals 90. I want to find both possible values of x, so I'm going to move that 90 degrees over. And I have x squared minus 5x plus 14 equals 0. Now I can factor it and solve. So I'm looking for two numbers that multiply to 14, but add up to negative 5. And I realize I just made a little calculation error here. 24 plus 60 apparently is not 104. It's actually 84. So let's try that again. So when I subtract 90 from 84, I'll end up getting negative 6. Okay, that works out a little bit better. So two numbers that multiply to negative 6 but add up to negative 5 would be negative 6 and 1. And then I can set those equal to 0. Once I solve this, I'll find out that x is possibly 6 or x is negative 1. I could double check and plug those back in. They will work, even though we have a negative value for x here. When I plug that back in, I'm still going to get a positive value for my angle. So we're good to go. So x equals 6 or x equals negative 1. And then let's try number 12. This one looks like a little bit of a doozy here. So we have the same idea that the two angles are complementary. So I'm going to take angle G, and I'm going to take angle H. And because they're complementary, I know that they're going to add up to 90 degrees. So I'm going to grab angle G, which we said was 3 times 2 to the x plus 46. And angle B was 2 to the x plus 12. And all this together has to equal 90 degrees. So again, put these together. This is the challenging part right here. We have 3 2 to the x's and another one. It's actually 4 times 2 to the x. 46 and 12 is 58, and that equals 90 degrees. Now in this one, we're not going to bring the 90 over. Actually, going to bring everything else over to the other side. So when I take away 58, I have 4 times 2 to the x, and that equals 32. So divide by 4, 2 to the x equals 8. So I'm looking for a power of 2 that gives me 8. That would be 2 to the third power, so x is 3. Now, good news is that supplementary angles, it's really the same type of idea, but we're looking at a different number relationship than we had for the complementary angles. So again, we're looking at all these yeses here. And if we do a quick glance, let's pick a nice number, 40 and 140 together. That gives me 180 degrees. If I pick 155 and 25, that also gives me 180 degrees. So based upon that, my definition of supplementary is going to be supplementary angles are angles that add up to 180 degrees. All right, again, algebraic definition of supplementary angles. Geometrically, if we have 180 degrees, we know that that's going to form a straight line. So if we had, let's say, an angle here, let's go 130, and we'll call that 50, or any relationship where they add up to 180 degrees, they form that straight line. So what's the geometric relationship? They form a straight line. All right, and a little typo here, we're going to call this actually S. So write a function definition, or defining the supplement of an angle S is a function of the known angle. So very similar to the complement, it's S of A. This time, instead of 90 minus A, it's 180 minus A. Change that to an S there. 4 and 5, any restrictions on the domain? Just like we had before, we want to make sure we're greater than 0, this time less than 180 degrees. We don't want to get those negative angles. And then 5, it's the same thing. Again, the supplement and the angle itself, they've got that relationship so that they add up to 180 degrees, so it works out pretty nice for us. And again, the algebraic examples, it's really the same thing as the complements. We're just changing that number from 180 if it's a supplement instead of a complement. And that's section 5, complementary and supplementary angles.